So now we're working with molecular formula versus empirical formula and how to find the empirical formula. And so let's look at the difference between them. So a molecular formula is really what we're familiar with right now. It's like a glucose, C6H12O6, all of those things. But an empirical formula is essentially just a simplified molecular formula. So like 6, 12, 6 all have common divisor of 6. So if you just divided them all by 6, you would get CH2O. And so CH2O is the empirical formula of C6H12O6. And so the meaning of subscripts in a formula is that they're the mole ratio of those elements. And so across an empirical and molecular formula for the same compound, the ratio is going to be the same. 1 to 2 to 1 is the same as 6 to 12 to 6. And so the best strategy for solving empirical formula problems is to find the moles and then to find their ratio. So you're going to start by converting from grams to moles for each element, which we've done before. And then dividing all the answers from step 1 by the smallest answer, and then using answers from step 2 as subscripts. And that's kind of wordy, so let's just kind of get to it. What is the empirical formula of a compound made of 1.04 grams K, 0.70 grams Cr, and 0.82 grams O? All right. So let's start with K, Cr, O. And so it's going to give us that starting value for K, 1.04 grams. And so to get to 1 mole, we look at that periodic table value as always, which is 39.10 grams, which multiplies out to be 0.0266 moles. Okay. Then we do the same thing with Cr. We're given 0.70 to start off with. Have to get to 1 mole. According to the periodic table, there are 52 grams in a mole, which is divided out to be 0.013 moles. And then oxygen have 0.832 grams given. And then in 1 mole, there are 16 grams of oxygen, which multiplies out to be 0.052 moles. Now the smallest number here is at 0.013. And so we're going to divide all of these two by that. And we're going to divide all of them, but 0.013 divided by itself is just going to be 1. (0.0266) divided by 0.013 is equal to about 2. 0.052 divided by 0.013 is about 4. So our final answer here for our empirical formula is K2 CrO4, because all of these just match up. So that K2 CrO4 is our final answer. And so now this is essentially the same question, except it's giving it to us in percents. And so this isn't really that tricky. You just give for working with percents, you just give the grams as if 100% was 100 grams. So this would just be 53.70 grams, 46.30 grams. So let's start with that. We have iron, 53.70 grams in one. So in 1 mole, there are 55.85 grams of iron. And that divides out to be 0.9615. And then with sulfur, it gives us 46.30%, but that's just going to be grams for us. And so in 1 mole, there are 32.07 grams of S, which divides out to be 1.444, 0.9615. That comes out, dividing by itself, is just 1. That one's the smaller one. And then 1.444 divided by 0.9615. It's going to be about 1.5. Now, we could write it as FeS 1.5, but that's a little icky, and so you're just going to multiply these by 2 to get a nice whole number of Fe2S3. And Fe2S3 is your final answer for that. And so now how are we going to switch from the empirical formula to the molecular formula if the empirical formula could be multiplied so many times? So we're going to find what's called a multiplier, which is just the molecular mass divided by the empirical mass. And so let's work with this example. What is the molecular formula if the molecular mass is 176 grams per mole and the empirical formula is C3H4O3? So that's nice. They're already giving us that molecular mass, which they will always, and they're already giving us the empirical formula. So that's really solid. And so first we're going to have to try and find that multiplier. So let's just set up that equation so we remember it. It's the molecular mass over the empirical mass. Now, we don't have the empirical mass given to us like we do the molecular mass, so we're going to have to find that. But luckily, they give us the empirical formula, and so we can do that whole thing where we multiply them out. So carbon has a mass of 12.01 according to the periodic table. Hydrogen has 1.01. Oxygen has 16.00. In our empirical formula here, we have 3 carbons, 4 hydrogens, 3 oxygens, and all of that multiplied out and added up, it's going to be 88.07 grams. And so now we have our empirical mass. And so then we just take that 176 that's given above and divide it by that 88.07, and we get 2. Technically, we get 1.998 whatever, but a multiplier always is going to be a nice whole number just to make things easy. So that 1.998 is really close to 2. Just round that one up. And so now we're going to take that C3H4O3, multiply it by the multiplier, which is 2, and that's going to come out to be C6H8O6 as our final answer. And so our last example here, what is the molecular formula if the molecular mass is 62.14 grams per mole and the empirical formula is CH5N? And so just to save time here, I've already calculated the empirical mass of CH5N is 31.07 grams per mole. Just to save time there, because we've been doing that whole thing here for a while now, and that's not the focus at the moment. And so to find that multiplier, let's take that 62.14 molecular mass and divide it by that 31.07 empirical mass. And that's also going to come out to be about 2. Actually, that was going to be exactly 2. Nice numbers there. And so then we're going to take that CH5N, multiply it by 2, and then we get C2H10N2 is our final molecular formula.